Allison, go ahead.
Two commonly used measures for wait. Two commonly used measures of, of center for a set of numerical data I can't read anymore.
Oh, no, it's okay. It's okay. There's a lot of big words, but I can help you get numerical data are the what?
Are the mean to median
Mm-hmm.
measures of center represent a central or topic no, wait, what?
Typical.
Typical value of a data set. The mean is the sum of values of in the set divided by the number of values in the set. The median is the middle value in the set when the value is arranged in numerical order.
Awesome. Thank you. So here we got two definitions. I want you guys to write these down in your notebooks. So mean and median. I'll give you guys about 30 seconds to a minute to write these two down. And oh yes, so my period 8 students, the few of you who are in my period 8, you guys already saw this since yesterday I had to leave early, so my period 2 didn't get to see what this whole section of the lesson. So you guys are basically going to be seeing a big review today, okay? All right, so finish writing if you're not done writing. But I want to talk about what this is before we start calculating it. So you've probably heard these words before. They're probably not brand new, but it's always good to kind of remember what they mean. So the word mean, there's another way to say that word. Does anyone know it? It's a very common word.
Equal to? Equal?
Mm-mm. Starts with an A.
Average.
Yeah, average. Good. Those two words are interchangeable. You might hear average, like the average score or his average grades or the average height or whatever. All of those, when you hear the word average, it means the same thing as the mean. Now, what it is the mean and the median are both a measure of center. So basically, like if I go out in the world and I ask a quantitative question, so let's say I asked all of you, how tall are you? I'm going to get a bunch of answers, right? I'll probably get like 5'3", 5'2", 5'5", 5'1", 4'9", and I'll just have like a long list of answers. Well, if I want to know the average height, what does that actually mean? What am I looking for?
The most popular height, like which height is more convenient?
Okay, so you're kind of on the right track. Most popular kind of is a little bit different, but you're on the right track because what it really is like if I take like a random student from my list of students, what is most likely going to be their height? So you kind of want to find like what is like the middle? Like where are most people? How tall are most people in my group of students? So like kind of like the most popular. That kind of makes sense. But what it is you're kind of measuring where is the center. Okay? So both the mean and the median do this, but they do it in different ways. So I'm going to reread what it says for mean. The mean is the sum of the values divided by the number of values. So here I have example A. And in example A, this is the test scores of a student. And he took 6 tests. He scored a 70, 74, 72, 71, 73, and a 96. So what you do first is you're going to add all of those numbers up. Okay, we add them all up and we're going to divide by the amount of scores that there are. So he took 6 tests, so I'm going to divide by 6. This is how we calculate the mean. So for all of these questions, it's going to be a little bit annoying, but you have to have your calculator out. You have to be ready to plug all those numbers in and get an answer. So let's go ahead and get in the habit of that. Calculators out. Phones are fine, but just be careful with your phone because sometimes when you're adding a bunch of things on your phone, you miss a number by accident. So just be very careful if you're using your phone. So what do you got? 70 plus 74 plus 72 plus 71 plus 73 plus 96. What does that give me?
456.
456. And now we divide that by 6. What do we get?
76.
76.
Good. Good, guys. 76. So that's his average. That's his mean. Now, look at the actual numbers. Look at all his test scores. Would you guys say that 76 is a good number of like what he tends to get on his tests? What he usually gets on his tests?
Yes.
Not really. It's like around a C, right?
Yeah, 76 would be like a C. But what are most of his scores?
74, 73.
Yeah, most of his scores are between what and what?
5.
74 and 70.
70 and 80.
Between 70 and 80. Well, I would say most of his scores. In other words, is there one that kind of stands out?
Yes.
Which one stands
The
out?
96.
Yeah, 96 stands out. Looks like he had a good day, or maybe he, I don't know, he maybe cheated, who knows. But if I don't really look at that 96, because that one's kind of like not part of it, what are the rest of his scores kind of from what to what?
70 to 73.
70 to 70.
70 to 75.
74, right? Yeah, 70 to 74. So is 76 a fair number to say, oh, this guy usually gets a 76?
No.
No.
Not really, right?
Yeah.
So that's why even though the mean sometimes is a great, and you'll see a couple of examples where the mean works well, sometimes the median might be a better number to use. So let's take a look at what we do for the median. So for the median, I'm going to read it. The median is the middle value in the set when the values are arranged in numerical order. So what that means is I have to put them in order from least to greatest. So right now I need to make my list, rearrange it. So 70, 71, 72, 73, 74, and 96. And then we're going to just look for which of those numbers is right in the middle. So what you have to do is, especially when you have a really long list of numbers, here's the strategy. We're going to cross things out starting from the outside and moving inwards. So first I cross out the 2 on the outside, then the next 2. Oops.
Both 72 and 73 are in the middle.
Right, and then both 72 and 73 are in the middle. So what we need to do is figure out what's right in between 72 and 73. And in order to
2.5.
Yeah, so in this case, it's kind of easy because those two numbers are right next to each other. So I know that 72 and a half, 72.5 is right in the middle. But in case they're kind of far apart, those two numbers, what you always can do is add them up. 72 plus 73 divide it by 2. Which if you do it in your calculator, 72 plus 73 is 72 plus 73 is 145, and then 145 divided by 2 does give me 72.5. Okay, would you guys say which of those two values, 76 or 72.5, is a more accurate number to say that, okay, the Niles tends to score around this number? Which one's more accurate?
The median.
The median, 72.5. Yeah, because most of his tests, not counting the one that he did really well on, most of his tests are kind of in the 70s, in the low 70s. So 72.5 is a little bit more accurate, a little bit more fair.
In the 70s, he goes up one each test.
Say that again?
When he was scoring 70s, he went up one each test.
Yeah, he kind of did a little bit better, a little bit better, a little bit better, and then he did really, really well. So as a teacher, I would be like, something's a little fishy with Niles. Maybe I should check up on him. All right. So I want you guys to now go ahead and take a look at example 5. On your own, calculate the mean and calculate the median, and then determine for yourself which of those two numbers is more accurate. So go ahead, I'll give you guys about 3 minutes. 3 minutes, go ahead. All right, guys, that is time. If you're still finishing up though, continue working and get an answer while I start going through this. So for the mean, we add everything up, and what am I dividing by this time?
By 7.
Yeah, I'm gonna divide by 7 since there's 7 numbers. So I've got 84 plus 94 plus 93. Let's go ahead and add all of that up in my calculator. I'm not gonna write it down, I'm just gonna do it in my calculator. So 84 plus 94 plus 93 plus 89 plus 94 plus 81 plus 90. I get 625.
That's where I messed up, man.
Oops. Always check if your answer doesn't look like it's in the middle of those numbers, then you know you did something wrong. So I know my answer should be in like the 80s probably. So 625 divided by 7, I get 89.28. Now, it's 89.285. So if I wanted to round to the nearest hundredth, what would be my answer?
90. I mean 29. 89.29.
Yes, good. 89.20.
Oh, I forgot to round up.
That's okay. 89.29 is my mean. Now for the median, very important, make sure that you write everything in order first. Don't just go crossing things off. Make sure that your set is already in order. So if I put this in order, I'm really bad at this and you'll probably see me mess up at some point because I'm really bad at writing them all in order. But here we go. 81, 80, 84, 9.
93 and 94, 94.
Perfect. Thank you. Okay, there's my list. Now I go ahead and I'm gonna cross things off.
90 is in the middle.
And 90 is right smack in the middle. I don't have to do any more work. That's my median.
I was confused at first because I remember with this one, like you divided it by 2.
Well, why did I do that?
Wait, was
Because
it?
you have to find what's in the middle. There was 2 in the middle.
Right, since there were 2 right in the middle, we had to figure out what's the middle of those 2 numbers. That's why I did that extra step in the first
Now
example.
we had to divide by something. That's why I put a question mark with the median.
Oh, yeah, no, when there's just one number right in the middle, that's your median. There's no extra work necessary. So what do you guys think? We have 89.29 and 90. Are these numbers, would you say that they are far apart or pretty close to each other?
Pretty close.
Really close.
Pretty close, right? So when that happens, both of those, the mean and the median, are both pretty good. Like you don't have to pick one versus the other. They're both good.
I was gonna say like the median would be a good answer because 90 is pretty common, like the 90s.
That's fair. That's a fair statement. I guess it kind of depends on what's being measured, but in this case, both, since they're so close to each other, you can basically change between one and the other. There's not really a correct answer. All right, so now, oh, hold on. I have to chat somebody back. Okay. All right. So now these were both, remember, the mean and the median tell me what's the best measurement for like the center. Like I want to know what is the most common, if I had to like guess where this person tends to be, that's what the mean and the median are for. Well, there's also, I'm going to skip this because you guys already did it on your own. There's also measures of spread. So center is the middle. Spread is how far away from the middle do I go? How far away from that mean, how far away from that median does my data set go? So this is kind of a long paragraph. I'm going to have you guys split it up when you read. Can I have one person read up to right over here? Just that first half.
I'm not reading anymore.
Anybody else then?
I'll read.
Go ahead.
Measures of spread are used to describe the how do you say that?
Consistency, yeah.
Of data values. The distance between data values, the distance from the center. Two commonly used measures of spread for a set of numerical data are the range and the interquartile.
Yeah, interquartile.
Interquartile range, IQR. The range is the difference between the greatest and the least data values. Quartiles are values that divided data set into 4 equal parts.
Perfect. Thank you. There's a lot of new words in there, so I appreciate you guys for trying them out because they are not easy words. So I'm going to be highlighting there's a lot of different things going on here. We have the range and we have quartiles. And I see that Allison wants to read the second part, so Allison, go ahead.
The first, wait, what's that word? The first
Quartile.
quartile is the medium of the lower half of the set of the second quartile is the medium of the whole set. And the third quartile is the medium of the upper half of the set. The interquartile range is a data set of the difference between the third and first quartile. It represents the range of the middle half of data.
Awesome. Okay. What's going on? Guillermo, is everything okay over there? I heard fire drills happening. Can you guys confirm, those of you who are in school? Oh, there's going to be a fire drill. Okay, it's not yet though, right? Okay, just let me know when you guys are leaving and I'll stop teaching.
Miss,
Yes,
are these box scraps?
we'll be doing that, yeah, in just a moment. On the next slide, actually.
We're writing this down, right?
Yes, so there's kind of a lot, I know. So that's why I'm highlighting everything in a different color. But we've got a few definitions here, and we're going to go through and I'll explain how to calculate each of them. All right. So go ahead and write these all down. I'll give you guys a long time, and probably everybody at school will be going on their fire drill in just a minute. So if we got to take a break, we got to take a break, and I'll wait till you guys come back. So right now we're just copying down all of these definitions: range, quartiles, first quartile, second quartile, third quartile, and interquartile range, IQR. All right, so you guys keep writing if you're still writing. What I'm going to begin doing right now is I'm just going to write this data set in order from least to greatest, because we always have to do that first. So finish writing if you're still writing, and if you're done, you can begin with me putting this into order, which is always, it always takes a while. So here we go. 3. Oh, there's a 2. Okay. 2, 3, 3, 4, 4. Oh, I missed the 3. See, I always mess up. Okay.
Oh, we had to write down the numbers?
You don't have to write the original one, but if you're done writing all
Mm.
your definitions, you can write the ones that I'm doing in order.
All right.
Okay.
There's only 1 5.
Only 1 5, right? What's next?
7 7.
7 7. 8. How many 8s are there?
2 yeah.
Just 2, right? Okay, 9s. 1,
This
2,
2 is 9. Yeah. 2
2
10s.
10s,
11.
1 11, 2 12s, and then a 14. Okay. So I've got all of these numbers. They're all in order. And so now what we need to do is we're going to calculate each of the things that I've highlighted above. So the range, I'm going to start with the range because that's always the easiest. The range is the difference between the greatest and the least of the values. So I look at my minimum number, 2, and my maximum number, 14, and I just subtract. So what is my range?
12.
12. And what that tells me is kind of like how wide is the data? How far apart are the first and last numbers? And in this case, they are 12 apart. So it kind of tells you like an idea, it gives you an idea of how like wide, quote unquote, how wide the data set is. Okay, once you've done that, the next thing to calculate always is going to be your median, which we already know how to do. So again, I've got all of these numbers. I'm going to very carefully cross things off starting from the outside till I get to the middle. Okay, I'm down to the last 2 numbers that are right in the middle. So what do I have to do?
Add them.
7.5.
So you can
Add
add them up
and divide it by 2.
and divide it by 2, which gives you
7.5.
7.5. Now 7.5 is right in between the 7 and the 8. So I always draw this arrow, and I think you guys should do it too because it's helpful, and I'll show you why in a minute. But draw an arrow right in between that 7 and that 8 to show that the median is 7.5.
Ooh,
Okay, the fire drill is starting for those who are at school. So if you're at home, you get some free time until they all come back. And you can ask me, you can use this time for question time if you have any questions.
All right. Okay, I didn't write it correctly.
Mm-hmm.
It's all over the place. And can I not put the arrow? Instead, I just like put the put it in parentheses.
Take the time right now to rewrite it correctly since we have time, okay?
All right.
Because and you're going to see why it's valuable to do it the way that I'm doing it. Okay, they're doing the fire drill in order, but I'm going to just pause here because I don't want you guys to miss out on anything, okay? So those of you who are in school, just focus on when you got to go. And like I said, if you guys have any questions about what we've done so far today, feel free to ask. I'm also going to pause the recording so all of this is not in the video. Alrighty, so we've calculated, like just to review, we've calculated the range, Q1, Q2, Q3, and the IQR. So in the next slide, I'm going to have you guys do it on your own. Let's skip, actually, I'll do number 7 with you guys just once really quick because it's pretty short. We'll do it really quickly, and then you guys will do number 8 on your own. So remember, the first thing you always have to do is put it in order. So for number 7, I would have 21, 24, 26, 26, 28, 31. Now, what do I find first?
The range.
The range goes first. Good, because that one's easy. Range is 31 minus 21, which is? Which is what?
10.
10. Good. All right. So now that we've got the range, what do I figure out next?
Median. Q1.
The median,
The median, which is also called,
the
IQ.
middle, wait,
it has another name.
Data? No. IQR.
Mm-mm. Q2,
Oh, I
because
thought.
Q2 is right in the middle. So I have 26 and 26, but
so it's 26.
it's just 26. Good. That's Q2. Okay, then I go on to find my Q1 and my Q3. So now I'm finding what's the median of the left half?
24.
Just 24. Good. That's Q1. And then you do the same thing for the upper half. 28. Now that I have Q1, Q2, and Q3, what can I calculate?
You have to calculate the IQR.
The IQR. Good. Remember, IQR is Q3 minus Q1. So what is that for me?
4.
28 minus 24, which is 4. Okay, so now I've got everything I need. So now go ahead and try number 8 on your own. I'll give you guys about 4 minutes to start on it, and then we'll finish it together. 4 minutes, start now. Okay, about halfway through. There's about a minute left. I'm just going to start writing these in order since that always takes a little while. All right, finish up. And that's time. Okay. What is my range? Who can tell me what's the range?
11.
11. 79 minus 68. Oops, 68 is 11. Cool. Median,
7.
where is it? I heard 73.
73.
Yeah, if you go from the ends and you cross things off, you'll notice that this number right here is right smack in the middle. So we're not between two numbers, we just have one value right in the center, which is a little bit different, right? In the last examples, usually we've had to cut it in half. We'd have to find the middle. So when I go to find, let me just write this down. When I go to find my Q1 and my Q3, should I include that number 73 when I'm crossing things off? No, we want to ignore it because otherwise you can't split it in half. You have to ignore it and use everything else. So when I go to find my Q1, don't touch that 73. I end up with
71.
71. Same thing with Q2. Do not touch that 73. We touch everything else though. And I got 75. Any questions on Q1, Q2, or Q3? Okay, cool. Now my IQR, what's that going to be?
4.
4. 75 minus 71 is 4. All right, any final questions on calculating all of these values? It's one of those things that just, you got to be careful, you got to do it. It's not hard, it just takes a little bit of time. Okay, so we finally get to the point where we're going to see our graph that I mentioned at the very beginning. Remember what I said, that today we're focusing on quantitative data and we're going to look at one way to graph it, and that is a box plot. So here is a box plot. There's another, has anyone heard of this in a different way? Because it has a different name.
I
You
saw
might have-
it before on, like, I believe on what's that? I forgot thing that Miss Steve told us to do, Mathia.
Mathia, yeah. So this has another name called box and whisker plot. So you might have seen it called both ways, but basically what it does is it puts these values, the minimum, Q1, Q2, Q3, and the maximum on a number line, and the graph helps you to visualize where those values are. So for example, in this set of data, they already did all the work for us. We have all those values. The minimum is 2, so they put a dot on 2. Then we've got Q1, which is 4. That matches up. Median is 7.5. Q3. And our maximum, 14. And what this helps you to see is, for example, in this example, would you guys say that the median is right in, is like an accurate measure of what the center is, or does that box kind of look a little bit like funky?
Uneven slice of pizza.
It's like a little bit uneven, right? So box plots are really useful because they help us to see if the data is very even or if it's a little bit like sloppy, a little bit uneven. And in this case, it's a little bit uneven. And I'll show you some examples of ones that are even. But before we do that, let's just quickly go over how to make one. So I've got this set. Let me see if the next one is shorter. Yeah, I'll do this one because there's just less numbers. It's a little bit easier. And we'll do this together. So the first thing that you have to do is exactly what we've been doing. Find all of those values that we talked about, Q1, Q2, Q3, and then we'll be able to graph it. So putting these in order, I get 15, 16, and I'm just going to kind of do this a little bit quickly, okay? So keep writing as I'm writing, keep following along. Oh, there was another 16, my bad. 18. 25 is next, yeah. 25, 25, 26, 26, 28, 28. Alrighty. Starting with my, well, I could calculate my range. Let's go ahead and just do that real quick. What's 28 minus 15?
13.
13. Okay, I got my range. Now I'm going to find my median. (25) and 25.
25.
So 25 is my median, my Q2. Okay, then I go for my Q1.
Wait, since it, that's different. If there's only like one number in the middle, you
don't use it. Yeah, so just be careful. If you're split between two numbers like we were, that's why I draw my arrow, because my arrow going straight down shows that, okay, now I can, one of those 25s, it belongs to the left side and the other one, it belongs to the right side, and I include those.
Is it just like dash and solid lines?
It's not really related to that, but if that helps you to sort of like connect it to that, then use that if it helps. All right, so we got my Q1 is 16. Now let's do Q3. Again, I use that 25. Q3 is 26. And I'm also just going to highlight my minimum, which is 15, and my maximum, which is 28. Because all 5 of those numbers, I'm going to put them on the number line, or like right above the number line. So I put my minimum right above the 15, my maximum right above the 28. Q1 is 16. Q3 is 26. And the median is 25. Okay, so I've got all these values down. Now we're going to create our box plot. So the reason it's kind of also sometimes called a box and whisker plot is because, let me go back, it has those two whiskers or kind of like arms coming out on both ends. So that's the first thing I'm going to draw is those two whiskers. So I just connect these two outer dots to each other. Then what I do is I'm going to draw my box, and my box goes from Q1 to Q3. So there's my box. And then the median, I'm going to draw a line going straight through it. So there's my box or box and whisker plot. Questions so far on how to create one? And by the way, we didn't do IQR, but let's do it right now. What is my IQR? (26 minus 16 gives me
10.
10. All right. Now, what do you guys think? Is this box plot nice and even or a little bit wonky?
Wonky.
A little bit wonky, yeah. But remember, what did I do? And let me erase a couple of things just to make this a little bit. Okay. When I got my Q1, my Q2, and my Q3, how many sections did I divide all of those numbers into?
3.
I cut it 3 times, but that created how many sections?
2.
Not 2. So I've got this portion over here.
Oh, I thought we were looking at the box plot.
We will in a second too. We cut it into 4 sections, right? And for now, I'm going to just call this section number 1, number 2, number 3, and number 4. How many values are in each of those buckets?
There are 2 values in the first bucket.
Mhm.
There's 2 more values in the second bucket. 2 values in the third, and 2 values in the fourth.
Good. So each bucket has this equal amount of values. And since we split it into 4 buckets, we can say that, okay, bucket number 1, that's 25% of the whole. This is another 25%. This is another 25%. And that's another 25% because I cut it into 4 equal, even parts. Now, on my box plot, this is also true. So from the minimum value to Q3, just this little section right here, that little arm, that's section number 1. This whole section over here, that's section number 2. This tiny little section right here is number 3. And that tiny little section over here is section 4. Now, even though those 4 sections hold 25, each of them has 25%, but are they even or uneven?
Uneven.
Very uneven, right? These sections are very uneven. So that tells me that the data that I have is not very normal. And I'll talk about the word normal in a little bit, but basically the data is like not very even. It's kind of like not divided in an equal way. All right. And I've been calling this section 1, section 2, section 3, and section 4, but they actually have names. So let me write those down. They're just called quartiles. So quartile 1, quartile 2, quartile 3, and quartile 4. And same as below. But I won't write it all down. But just remember that even though it's uneven, quartile 1, that tiny little section, has 25% of the data. This big old section in the middle has 25% of the data. So does this one. And so does that one. Do I have any questions so far? Now, you might be thinking, okay, Ms. Lopez, these graphs are very uneven. Are you ever going to show us one that actually looks normal? And the answer is yes, I will. Let me show you one right now. Okay, so for example, here's one that is a little bit more normal. Now, it's not perfect, and they're not usually going to be perfect because remember, in the real world, if I'm collecting data from actual human beings, that's never going to be perfect. Humans are not perfect and life is not perfect. So I'm never going to get anything perfect, but this example is a little bit more even than all the others. Do we agree with that?
Yes, because Q2 is in the middle.
Q2 is pretty much right in the middle, and everything is cut a little bit more evenly. Let me see if there's another one. Which of these, the top one or the bottom one, is a little bit more even?
Bottom.
Bottom one, do we agree? I'm gonna hope that was a yes. And I think that's the only even ones I have in this PowerPoint, but just so you guys know, they do exist, but they're not very common. Because like I said, in the real world, data is not usually going to be very even. All right, so now that we kind of see how to make a box plot, let's see if we can interpret them a little bit, because this is more what it's gonna look like on a test. So the box and whisker plot shows the number of baseball cards collected by 15 children. John has collected 523 baseball cards. Which statement must be true about John's number of baseball cards? All right, so if John has 523, where is he going to be on this graph, on this box plot? Where does that number fall?
The 523, it falls for the range.
Remember, the range is just a calculation. It doesn't actually represent much. It just tells me how wide the data is. But my question is, which section of this graph, which section of the box plot would 523 fall into?
C.
The third quartile.
The third quartile. Very nice, Samantha. So remember, the first section right here is quartile 1. The second one is quartile 2, and the third one is quartile 3. And the number 523 falls in quartile 3, because if you look at the number line, and I'll erase these arrows for a second, if you look at the number line, 523 must be like somewhere around here, in between 500 and 600. And I know that it has to be a little bit under the number 584. So I know it's somewhere in this section, in this whole section.
Okay, I understand. I'm sorry. I was a little confused.
That's okay. That's okay. So that's the section that he's in, quartile 3. And taking a look at the answer choices, well, we already see which one it must be. But let's actually talk about all the other ones because they bring up something important. First of all, I haven't talked about mode yet, but does anybody know what it is? I want to see before I give it away. Okay, I haven't talked about it because the mode is never a useful number, but the mode is the most common answer.
Write this down.
Yeah, you can write that down. But again, we won't use it ever because it's never going to be the best measure for anything. Because, for example, let me very quickly go back to this problem. Which number comes up the most often? Is there a number that comes up more often than the rest? Actually, in this one, there isn't. But notice how the number 16 comes up twice, the number 25 comes up twice, 26 comes up twice, and 28 comes up twice. So they're all tied for the mode, because the mode is whichever number comes up most often. That's all it is. But it's never necessarily going to tell you anything, because sometimes the mode is in the middle, and sometimes the mode is somewhere else. I'm trying to see if there's a good one around here.
The mode could be the one that I said that the 90s was the most frequent.
Yeah, the most frequent. Look at number 8. There's a good one here. In number 8, which number comes up most often?
71.
71 comes up the most often. But is 71 in the middle?
It's in quartile 1.
No, right? It's in quartile 1. It's like way off over in the lower half. So it's not a good measurement of anything. It doesn't really tell us that much. So that's why we don't really use it. But it's always good to like know what it is. The most common answer or most frequent. Okay, now we already determined that it's going to be in the third quartile, so I can already circle B. But let's talk about what these other two are. The 25 to 50% range. Let me make a bigger box plot just so I can label it a little bit better. Just a random box plot. Remember what I said. Remember how I said that this section holds 25%? Or every section holds 25%. no matter what. That's what a box plot is. It divides the data into 4 equal parts. So every section holds 25%. Now, which quartile would be the 25 to 50% range?
The first two.
Yeah, so kind of, you're close. If it was the first two, it would be from 0 to 50. But this is talking about 25 to 50, so where does that have to be?
Quartile 2 and quartile 3. I mean, wait, the blue one and the green one.
Yeah. Wait,
You guys are really, really close.
isn't it just blue?
Just blue, yeah. Because if I'm measuring, this is 0, this is 25%, this is 50%, this is 75%, and this is 100%. So
Oh.
from 25 to 50, that's quartile 2. Okay, so this means the same as quartile 2. What about the 50 to 75 range?
Quartile 2 to quartile, just quartile 3.
Yeah, this whole section, quartile 3. That is the 50 to 75 range. So on a test, I really like this question because this shows the way that they phrase it on a test. On a test, they might call those sections by their quartile. So they might say quartile 1, second quartile, first quartile. They might say that, or they might use the percentages, and you have to make sure to know it both ways. So if they say, oh, it's in the 75 to 100 range, where am I looking?
Quartile 4.
Quartile 4, that's my 75 to 100 range. All right, so again, you can see it both ways, you might see it both ways, and you just need to understand what they're talking about. So any questions on that? Cool. All right. Let's do one more. I think we'll have, well, we might have time for 2 more. Select the box plot that represents the given test scores. So now this is a very common test question. They'll give you a set of data and then you have to see which box plot is correct. Well, in order to match it to the correct box plot, what do I have to do?
Can you repeat the question, please?
Sure. So in order to match my data to the correct box plot, what should I calculate? What should I find?
We first have to find the range. I mean,
Like-
no, the median.
Okay, so no, you're right with both of those. We could find the range. Well, for the range, I need to know my smallest number and my largest number. And I can quickly go and look at all my graphs to just make sure those match up. So this should be 48. Is that good?
43. Oh, that's the equal to the range. I'm sorry.
Oh, I see what you mean. So just go ahead and double check that these both are at 48 and 91, and it looks like they are for every single one.
Can't use range.
Okay, so all of these are good as far as the maximum and the minimum. So that doesn't help me out. What should I find next?
We can't find the quartile 1 and quartile 3 because they're all
median?
have the same quartile 1 and 3. We have to find quartile 2.
Quartile 2, the median, yeah. So I go through and I'm going to go ahead and find my median. And that will probably tell me which answer is correct. All right, between 77 and 78, I get
77.5.
77.5. So let's check. Answer choice 1, does that look estimating around the right place?
Yes.
Yeah, that seems okay. What about answer choice B?
Yes.
Yeah, that looks fine. What about answer choice C?
No.
Nah, that's way off, right? That's below 70 or 75. So that's definitely out of the question. And D?
No.
No. Okay, so I'm getting closer, but now I need to do one more thing. What else should I find?
The Q1 and Q3.
Yeah, Q1 and Q3 will give us our final answer. So for Q1, let's go ahead. Let's see what I get. What's between 64 and 68?
66.
66. So this should be 66. Does A look okay or no?
Yes.
It might be. It kind of looks like it's on the 65, but it might be a little bit above 65. It's kind of hard to tell. What about B?
Yes.
Yeah.
It might be okay. It might be okay. I'll leave it for now. Let's find Q3 just to finalize. Between 82 and 86, what do I have?
84.
84. So this one seems to be like right on the 85, whereas answer choice B, which one looks better?
B.
B.
B might look a little bit better, right?
Yeah.
All right, so it's a little bit of a close call, but B does seem to match a little bit better. And that's what you have to do, okay? So we really just have to find those values and match them on the box plot. Do I have any questions on that? Awesome. All right, we have about a little bit less than 10 minutes. I think we can do this one. This can be our last one. So this is kind of the opposite. Rather than choosing the correct box plot, now I have to choose the correct data to go with it. So here's what I want you guys to do. Since we don't have a whole lot of time, I'm not going to make all of you do all four. But let me see. Okay, when I call your name, you're going to check answer choice A. So the following, I'm just going down my list. Karina, Christopher, RL, and Lori Hayden, you look at answer choice A. The following people look at answer choice B. Naomi, Juan, Chloe, and Samantha look at B. Actually, I'm going to add Shania to that too. Shania, you too. All right. The following people look at C. David, Jade, Anaya, Allison, and Nijira look at C. And then everybody else look at D. And you're trying to see which one matches, which means you're going to need to know all of those values, Q1, Q2, Q3, as well as the maximum and the minimum. And if you think you have the winning answer, just let me know in the chat. Oh yeah, this should be 5. All right, we have about 4 minutes left. So anybody, if you think you have the winning answer, I see a couple people already told me, go ahead and put it in the chat. All right. Yeah, it looks like group C had a winning answer. So I'm going to check just answer choice C. And if you had a different answer choice and you think it might have been correct, let's just see why this one is. So I have 5, 9, 9, 10, 11, 14, 14, and 17. Okay, starting with, I already checked, okay, the maximum and the minimum are good. In fact, that's fine for everything, for all of them. So I have to start with the median. Wait, did I skip a number? 5, 9, 9. Oh, I think C might not be correct. Why would it not be correct?
Because it's 10.5.
Yeah, this is 10.5. That was my bad, guys, sorry. So it's actually not C. Oops.
I think it's D.
You think it's D? Let's check it out. D, 5, 9, and I'm just going to do it down here. 5, 9, 9, 9, 13, 13, 15, 17. Okay, here we go. What's between 9 and 13? And remember, you can always check by adding them up, 9 plus 13,
11.5.
and dividing it by 2. 9 plus 13 is?
22.
22, and 22 divided by 2
11.
is 11. So it is 11. So that's good. That checks out. And now I check the rest of the values. I should get 9 for my Q1, which I do. And I should get 14 for my Q3. Between 13 and 15, what do I have?
14.
You
B
do have
and A
14.
also at the middle is also 11.
So for B and A, even though the median was 11, if you check Q1 and Q3, those numbers would have been off. They would have been wrong. So D is our answer. The rest just don't work out. Now on a test, you would have had to check every single one because you have to make sure, you have to be absolutely certain of your answer. All right, that leaves us, that's it. That's the end of class. So the rest, the last couple of slides I had, we'll do tomorrow. And don't forget, you do have an assignment due tonight at midnight. So if you haven't done it yet, better do it today. Finish that up so that your grade goes up. Have a nice day, everybody. I will see you all tomorrow.
You as well, Ms. Lopez. See you tomorrow.
Thank you.
Bye, Miss.
Bye.
Bye.
Bye-bye.